Afternoon, everybody. Morning, if it's still morning where you're at. Thanks for joining us today. Give folks a minute or two to get joined here on our webinar From Address to Actionable, Public Safety GIS to Support NG9-1 and Field Response. Oop. Yep. Okay. Not muted anymore. Okay, good. All right. We got a good number here, so let's go ahead and get started. Again, appreciate everybody joining us today. For our monthly webinar series, you get to see my face one more time. Lucky audience. We are going to be varying our webinar presenters here in the next couple of months, bringing on some panels that I may moderate, but you'll get to hear from some other voices along the way, which is always a good thing. But really appreciate everybody joining us for today's webinar. We're going to talk a little bit about addresses, subaddresses, dispatchable location, indoor mapping, and where do we start with that big ball of wax? So let's jump right into our webinar here. I'm going to go ahead and turn my camera off so I can preserve my bandwidth and get into our content. You know, there's a hard truth out there that has to do with the challenges that we as GIS professionals face to make sure that public safety has all the advantages that we can offer, as well as opportunities to improve response times, cut down on call transfers, and all the lofty goals that we have in terms of supporting public safety with technology. So we're going to talk about that hard truth. We're going to talk about three types of data that play three roles, right? Addresses, subaddresses, and dispatchable location. All do three different things. I'm sorry, not dispatchable location on that one, but indoor mapping. Addresses, subaddresses, and indoor mapping. They sound like they're independent and disparate from one another, but in fact, they are very much related, and there is great convergence coming together in the sum of those three parts as we are moving forward in 2026. I want to emphasize as well in the third bullet point here that indoor mapping and addresses and subaddresses are not our partners, not competitors. So we'll talk about that for a minute. And then what do we do about that? Where do we start? I'll offer some thoughts about that as well. Uh-oh. Are you able to hear me? I seem to have a chat indicating maybe you don't. Somebody could just chat in and let me know. Okay, good. You're hearing me. Great. Thank you. All right. Volume went down. All right. Let me speak up a little bit louder then, and we'll carry on. Thank you for that. And great note, as always, if this is your first webinar with us, we invite everybody to use the chat to ask any questions, to discuss with other participants anything you want to discuss. If you would like a response from me on a question, please ensure that you're using the chat to host and panelists so that I'll see that, as I will not be able to monitor all the chat until a bit later. All right, all the mechanics out of the way here. Let's get right into the meat of our discussion. What is this hard truth I'm talking about? Well, if you are a GIS professional that supports public safety, that deals with addresses, road center lines, you know that the biggest challenge you face in terms of completeness in terms of readiness for NG9-1 may be accuracy, but more than likely it is completeness. Accuracy, there's a lot of great tools out there. We certainly have one in our VEP tool that helps QA/QC GIS data so that you can see the places, you shine the light in the dark corners and see the places where you may have an accuracy or consistency concern. But what's challenging is once we get through all of that work, do we have all of the road center lines, all of the addresses? It's pretty hard to miss road center lines, though it happens. We can certainly put in business processes to ensure that when road center lines are added, approved by a planning commission or anybody else who would approve them or built, that they can get added. Addresses, on the other hand, are kind of a whole other animal. A lot of challenges around making sure that we have every address in our database that we could have and that we should have. Subaddresses even further because it is a pressing in on precision in terms of attribute data about addresses. And we'll see a demonstration of that here in just a minute. But subaddresses are definitely not on the top of people's lists because we're still working to be sure that we get complete main addresses, and reasonably so. That it's a big effort, but definitely needs to be done. Subaddresses probably is on the back burner for most of you. And again, probably appropriately so because you're prioritizing your resources, executing on the most important things first. However, indoor mapping comes along and, is a topic that in some ways is a distraction, to be fair. It takes up some time then when the folks at the PSAP say, oh, I have these indoor maps from a school initiative, for instance, a school safety initiative, or the fire department does its structure pre-planning and they are indoor maps and I would like to get them into my system. Perhaps that is a distraction away from your ability to ensure that you have the complete and accurate address points and road center lines that you need as well. So there's a lot of indoor mapping and school safety initiatives that are advancing these days. So a lot of that data is coming your way. Whether it's data or not is a question you should be finding out, and maybe part of how it actually puts more on your plate because it's not data, it's graphic, for instance. And then there are fragmentations in terms of who's supplying who data, who's the data owner, who's the data steward or the aggregator, right? I know I certainly sat in a seat in Texas at Greater Harris County, excuse me, Greater Harris County 911 in Houston, where I was not the data owner. I wasn't strictly speaking a data steward either. I was an aggregator, but being an aggregator gave me the opportunity to see things at that 35,000 foot level and see where there were issues that made me sort of fill the role of a quasi steward sometimes, but I always had to push it back down to the data owners to address, to fix, right? And there was great fragmentation of having many cities that I had to get data from, put together, keep updated, and it's a major challenge. It's the hard truth. Let's talk a little bit about, let's take a step back. Let's set our foundations firmly on what we're talking about here, and then we'll dive into what there is to do about these hard truths. Three types of data, three roles, right? Most of you, this probably isn't news to. Some of you, perhaps it is. There's addresses, which identify the structure. What is a structure? Great debate. Not going to have it today, but identify the structure with a main address point. Subaddresses identify where help is needed. So I'm going to connect the idea of dispatchable location, and we'll dive into the details of what dispatchable location is and is not in just a moment. But I'm going to connect this concept of dispatchable location to the capture of subaddresses. You can, well, all right, I'll say this way. In some cases, you cannot have a dispatchable location without subaddresses. And we'll talk about Ray Baum's Act here in just a minute as well. there is a requirement for carriers to be sending in, a dispatchable location, a verified, validated, actual location of where a caller is. This is particularly challenging in a sort of traditional business phone system setting, a VoIP typically setting. Multi-line telephone services, MLTS, providers have this requirement. And so they have systems in place where a property owner could set, actual locations for the handsets that sit on somebody's desk, at their seat, in their room, in their unit, in their floor, in their building, potentially even with data model v3 in their site and structure. We'll talk more detail about that in just a moment as well. Last point here, indoor maps guide responders inside. You can imagine how that works, but there is absolutely a connection between all three of these things. They converge. This convergence has been really sort of gelling in my mind the last couple of months, especially a lot of conversations about how these three things to go together in the NINA indoor mapping RAQ working group. A lot of conversations about these convergences outside of that working group as well, in different events that I've been a part of recently. The Critical Issue Forum, there was some others as well. And so that's why I'm bringing this to you at this time as part of our webinar series, because I think we need to set ourselves a firm foundation of understanding about what these three things are, and then the convergence or overlap and how these three things come together. So I'm going to put a couple of pictures up here in the next slide, next few slides, that will demonstrate what I'm talking about. What we have here is screen captures of the different pages of the NINA STA 006, which is the NINA NG9-1-1 GIS data model standard, an ANSI standard. It has recently been certified as with a stable form notice in V3, so I feel comfortable sharing these updated tables and updated fields for V3. So I want to emphasize that again. If you're seeing something that doesn't look right to you, what you're looking at is the V3 table structure for site structure address point layer in the NINA GIS NG9-1 GIS data model. What I'll point out is that on the left, the highlighted box there are the fields that would create an address, right? When I say address, I mean a civic location. Civic location includes house numbers, street name elements, as sort of what I think of as the main address. Further down the table, as you see on the right, the subaddress elements, and again in V3, they're proliferated even more than they were in V2 and V1, move into these things like sites, subsite, structure, floor, wing, unit, section, row, room, and seat. So there is a lot of granularity there, a lot of granularity. And usually when that conversation of subaddressing comes up, it's because people are and feel overwhelmed at the prospect of building and maintaining GIS data all the way down to that seat level. I like to emphasize to folks in those conversations that you don't have to go all the way to the seat level because there's a place in the schema for it. You also don't have to go into that subaddress level if there's not a reason to. So a single family home, for instance, in most cases, without something like an additional dwelling unit or an ADU, probably will never have that subaddress element and parts of the schema attributed and populated. But there are probably more than you think places that could have this and probably should have this subaddress information represented in its attributes. People tend to think of indoor mapping, which we'll talk about in just a moment, but I want to again connect the concept of what indoor mapping does to the concept of what subaddress information does. Some people think of both of those things as only a big city problem, only a high-rise building problem. And when you take a step back and think about what facilities actually would be appropriate to give a subaddress or an indoor map that may need to connect with those enterprise MLTS providers via the Ray-Bombs Act requirements that I'll talk about here in just a moment. There's more than you think. There's lots of mid-rise buildings, 3 to 5 stories, maybe even just 2 stories. Lots of schools, lots of public facilities, government facilities that may only be 2 or 3 stories that need to have the subaddress element because of kind of the likelihood of some sort of big event happening, right? These types of events that I'm talking about are the ones that are low frequency, high impact events. They don't happen that often, but when they do, they're big. Where could that happen? Well, it could happen almost literally anywhere, and any place that has more than one building, more than one floor, potentially would be a good candidate to ensure that you have subaddress information. Again, not saying stop adding to and completing your address points, your main address points in order to do that, but start thinking about what are the facilities that may need this data at some point in the future, and what is my plan to get that data captured and maintained at the time when I have the resources and bandwidth to do so. Before I move on, I see a little bit of chat action here. Let me just take a quick look at that. Looks like there's some good chatter going on there. Nothing I need to immediately address. Thank you for participating there. I love the fact that you guys are chatting with each other throughout the conversation. And I'm excited that the topic is bringing some conversation. Keep that up. Indoor maps, then, how does this relate? Again, is this just a distraction? Is this just like, hey, we can make indoor maps, so we should? Let's talk a little bit about how indoor maps contextualize place, and let's talk about the relationship between what I just demonstrated with the subaddress information connecting to what an indoor map represents and what it does. So it contextualizes, and it's always fun to eyes a word, right? Contextualizes indoor spaces. So I just want to point out, and you can see with the colors of the arrows, the various pieces of an indoor map that are represented typically by polygons, but could also be represented by an address point with subaddress information. And this is where the connection occurs, right? This is where the relationship is expressly connected. The structure has a polygon. The floor has a polygon. The unit has a polygon. If there's multiple wings of a structure, they can have their own polygon. Rooms and seats can be represented by polygons as well. If you have that enterprise MLTS phone system, or you have a vendor as a 911 authority, you have a vendor that you want to get that data from, so that when they send a 911 call, they do so with a validated location as they're required to do, and that it connects to, you can connect them to the data of a point as in a subaddress, or you can connect them to the data of a polygon. My colleague Deb Roseboom co-chairs the NINA NG9-1-1 GIS data model working group. And she was telling me about the many conversations there were around this topic there. You know, as well as the indoor RAQ will call for data model to be created. Will it be an indoor data model, or will it be merged into the NG9-1 GIS data model, thus making it a 911 GIS data model? That's a question nobody has the answer to yet. The debate hasn't occurred, but it will probably in short order as the RAQ document is completed, probably in the next few months. This will become very relevant at that point. The crossover, the convergence, the bringing together of those points of subaddress information with those polygons of indoor mapping polygons, and maybe not, maybe just a site structure address polygon as well. This is a new concept in V3 that we'll be looking forward to talking about in April on our webinar. Deb is going to join us in the April webinar because we anticipate the final publishing of the NG9-1 GIS data model by that time frame. So she's going to bring all the changes to you and information about the discussions in the working group there. But in regards to this, it all comes together here with indoor mapping, subaddresses, and dispatchable location. So what am I talking about with dispatchable location? Right. Before we go there, just to emphasize this convergence that I'm speaking of, right? Addresses form the foundation. So accurate and complete address data set is absolutely the first step that has to occur. Subaddress points can add precision to the information that connects to those MLTS delivered validated 911 locations as civic addresses in some cases. Site structure address polygons are available in V3, as I mentioned, and indoor mapping polygons connect the data and it completes the circuit. So what is a dispatchable location I keep talking about? It is a very specific thing, well defined in federal regulation by the FCC, as you see quoted here. A location delivered to the PSAP with a 911 call that consists of validated street address of the calling party, plus information such as suite, apartment, or similar information necessary to adequately identify the location of the calling party. This is where subaddresses becomes lifesavers. Ray-Baum's Act, which is where this definition is located, requires precise location information be provided by large enterprise phone systems, largely based on VoIP, to both on-site personnel and the PSAP. And the VoIP, POTS distinction is irrelevant, but I just point out the fact that VoIP systems are managed by software. Therefore, the people who are managing those systems have the ability to, I'm not an expert or user on those systems, so I'll say easily, not having the actual experience, but they can easily sort of maintain that information. And if a phone is picked up and moved from one desk or seat or room or wing or building to another, they have the ability to adjust that and update that in their systems. That doesn't bear, to my understanding, in most cases, it doesn't bear a relationship to GIS data or spatial data of any sort. But I think as 911 authorities, as GIS data providers, we should do the things we can do to help those connections exist. The intention of dispatchable location and Ray-Baum's Act in general is to reduce emergency response times and improve the actual outcomes of those calls with precise location of phone systems that may not be coordinate based. And I'm not an expert. I'll say, by the way, put a big asterisk on this entire slide. I'm not an expert on Ray-Baum's Act. I am not pretending to be one. I did not stay at a Holiday Inn last night. So this is my best sort of understanding of it, and there may be some flaws in that. So I am open to hearing about those if you know about it. But my understanding is that's a key component of that, and connecting that to spatial data is the best thing we can do. Big order, lots of resources, again, need to be prioritized and executed. So it may be down the road, but we need to be thinking about that and planning for it. So I just want to establish here that what we're talking about in terms of addresses, subaddresses, indoor mapping polygons, address polygons are partners, not competitors. I want to emphasize that we should be focusing on the foundation. I think I've said it several times already. Our foundation is road center lines and side address points or side address polygons, however you may choose to roll. But we should also be setting ourselves up to take advantage of the opportunities that exist for the development of indoor mapping out there. There's a lot of, in particular, school safety measures. Some come with funding, some don't. Some are mandates, some are not. Some are suggestions, some are requirements. They run a wide spectrum. But if you have opportunity to take advantage of any of those, the the information that you get and or the data that can be extracted from them becomes very useful, not just for school safety response or a particular type of response, like in the case of the fire structure pre-plans, but also for all the other things that an indoor space polygon in a GIS could be useful for in your dispatch systems, in your tactical mapping systems, in your police department's asset management system, in your police department's real estate dealings, city, county, fill in the blank. The uses far exceed public safety uses of indoor mapping data. So the only point is don't don't look a gift horse in the mouth if you have an opportunity or somebody brings you some indoor mapping data or an indoor map that doesn't have data, that is just a graphic. What can you do to take advantage of the fact that that has been created, especially when it's created in a GIS format, to help close this gap, close this circuit, and embrace the connection between addresses, subaddresses, dispatchable locations, and indoor maps. This is my point today. How do we do this, right? How do we scale this ability to connect spatial data to dispatchable location? My recommendations start with high risk facilities. Again, the high impact, low frequency event. Where would that happen? What's the likelihood? Schools are an obvious example. Multi-unit structures of any sort, large public gathering places such as government facilities, but also things like malls. There are many terrible, low frequency, high impact events that occur at workplaces of all sorts. Um, you focus on these sort of multi-unit structures and you use data models that scale. What do I mean by that? In particular, I mean that as NINA creates a standard around indoor mapping, which it hasn't done yet, I am a part of the working group that's writing the requirements to do so. ISF or 2 or 7 will proceed out of that work group in the next couple of months or so. And those ISFs will be divvied up into other NINA working groups that will need to create documents that may be standards, documents that may be information documents about data stewardship, data creation, for best practices as well as standards. That your data model will scale because it is based on a standard. And so I want to emphasize that those standards are coming to you and they'll be here as quickly as NINA can get them created. So you'll want to pay attention to that and be aware of the details of that when the opportunities come. So there's lots of school mapping initiatives out there. Strike while the iron is hot. Don't let the opportunity pass. Will the opportunity, taking advantage of the opportunity, make you do more work? Probably so. It will be a resource planning activity as well. So there will be some challenges there potentially that you'll have to address. But my recommendation, my advice is do what you can do to take advantage of them. And if you can't do anything to take advantage of them, then don't, because you don't have resources. So keep focused on your day job, of course, but don't give up on the idea that there is value in this connection. So where do we start with this? I've emphasized a couple of different times that your main address points and road center lines are the foundation, absolutely the foundation. So in many cases, in places where I've worked or as I've been a part of Datamark, many jurisdictions we've worked with, they have many addresses in many databases. In particular, if you are in that data aggregator, that sort of 911 authority or GIS data provider role, where you're bringing together many databases from many other jurisdictions to do things. Do your best to create a best-in-class master address database. I was with a client just a couple of weeks ago where they were taking me through the struggles that they have with the many different data sets they have that are created by different people with different missions, but they need to bring them all together into a public safety master address database. It's a big effort. Let me tell you, it's a big effort. And in particularly in a place where you've got a lot of address points that you need in order to be complete, or you've got a lot of address points that you know are out there, but not necessarily in your master database or not accurate. There's a lot of QA/QC activities to undertake. You have to, again, undertake a resource planning effort, make a plan, execute it, create a best-in-class master address database. That's one bullet point on a slide in a webinar that is easily said, difficult to do, but we help, right? We can help with that. That's where we shine and our expertise is strong. You can reconcile the many to the one then. We have, I'm going to talk about a case study here in just a moment, but we have a service we call Address Comparison and Evaluation, ACE or ACE, you may hear about it. And what it does is actually do a weighted analysis and comparison of the value of the various and sundry databases against the number of times a particular address occurs across those databases, weighted with the quality of those databases, to come up with what we call a candidate list. So in this use case study is about Alabama. I'll mention another one as well that I did worked on. I didn't do it myself. I worked on it though, and a team of us did it together for a large city in the Bay Area of California, where we started out with a pretty decent master address database of about 150,000 address points. We compared 5 or 6 different databases, things that included the registrar of voters, the parcel situs addresses. They included things like the alley, because that is a highly vetted address database, civic address database. Um, to my best recollection, we had a utility database that had a lot of great addresses in it. All of those had varying degrees of sort of trustworthiness. The voter roll database in particular was lower on that scale because there was less vetting of an address that might be submitted. So there were many addresses that were sort of the same address, but they were fat fingered or changed in terms of how you spelled Main Street, for instance. Then we had the alley that was highly vetted on the other side of the spectrum, where if an address gets in there, it has to be MSAG valid. It's probably pretty trustworthy. So we weighted that one pretty high. Utility database got weighted pretty high. The sited address of parcels sometimes is questionable. Sometimes is more of a mailing address than an actual situs address. So we weighted that in the middle. We put all that together. We had deduplicated all the addresses that occurred, and then we accounted in our matrix how many times did this address occur that was not in our master address database GIS data set, but it occurred across these 5 databases. If it occurred in 5 databases, all spelled the same way, it's pretty trustworthy. We can add that to the list of candidates. If it occurred in one database, in particular, a lower value database or a lower trustworthiness weight database, probably don't need to add that to the list of candidates because we're not sure we can trust it. the output is this candidate list that proposes addresses that you don't have in your master address database, but are very trustworthy and full of reasons to add them to your master address database. There's a whole separate effort to go and place the location of them, but we, in this particular case, in this city in the Bay Area of California, we added about 185,000 addresses to their master address database, doubled the size of it plus, and found some very interesting results in terms of the proliferation of subaddresses. Units were found that hadn't been in the database. Probably of that 185,000 that we added, this is my best recollection, about 75,000 of those were subaddresses. So it's a great way to find subaddresses as well that enriches your data, increases the precision of your data sets, and connects to all that indoor mapping that is going on out there as well now. Here's the Alabama statewide example as well. We had 85 emergency communication districts, ECDs in Alabama. The 911 authorities, they submitted their address data, went out and got all of their comparison databases, did the weighting exercise, came up and added to the state of Alabama's aggregated address point GIS data set 600,000 address points. In a state with 4 million or so people in population, that's a lot of addresses, and come out with a much more trustworthy and reliable master address database. At this same time, and I'll freely admit, all of the reduction in these transfers, down 90% from the data. Those are not all due to the fact that they went out and did a statewide ACE, but I guarantee you many of them were, because the accuracy of their call routing in an NG9-1-1 system improves. The more trustworthy data, the better the call routing. That's a relationship that is well established. So what do you guys think? I see some chatter going on here. And I just want to take a quick look through the comments and see. Wow, there's a lot of good conversation going on there. If anybody has any particular question or comment that you'd like me to speak to, please just add it to the chat here. In particular, I want to make sure that everybody get your thoughts on that connection, that convergence that is occurring there between the addresses, subaddresses, dispatchable locations, and indoor mapping, probably throughout the chat already. And apologies about not being able to keep up with that. But that's what I've got for you today. Really appreciate you spending some time with us. I'm going to go ahead and let you know about our upcoming webinars in March. I'm excited about this March webinar. I'm going to be moderating a panel of some AI experts. And we're going to talk about not how anything to do, honestly, with how Datamark uses AI or will be implementing it into our products, but instead it's really going to be a foundation. It's really going to be a primer. It's going to be a crash course, if you will. So if you understand what a large language model is, what natural language processing is, what GeoAI is, what all the kind of buzzwords are, then I'd love to have you come join us and join the conversation in the chat. But that is going to be the focus of the March webinar, is the basics of what is a LLM? What is NLP? Why does it help me? How does it help ChatGPT and Copilot and Claude and all the offerings that are out there do what they do? What is it to train a model, right? How does that happen? We have a number of AI experts here at Michael Baker International. We have partners out in industry that we have recruited to join us and help us make sure that we keep this foundation level, educational about what the buzzwords are and what they mean in AI and how that may or may not relate to GIS. So that's an exciting opportunity there in March. And then in April, breaking down NGCS actually may or may not be that topic in April because of the timing of the approval of the NG9-1-1 GIS data model. So I should have another sign up for you over there for that one. But scan these QR codes, share them amongst the community. If you're interested in these topics, join our webinar in March and April as well. I see maybe some specific questions here in the chat. Let me just take a look here. Oscar, any thoughts on funding as the key basis to address improvement on topic? Yeah, funding's it's always the elephant in the room, right? It's the thing that allows us to do lots of things or holds us back from doing lots of things. We all want to do lots of things. We're in this industry because we are helpers and improvers and doers, but we can only do so much with the resources we have. Funding, and this is exactly why, and I'll just back up my slide here. This is exactly why I have this concept in the discussion today. Don't look at these as competitors, look at them as partners, because here's the thing. If you don't have address points, great address points in your foundation, but you can get somebody to go out and make an indoor map because there's a school safety initiative that has funding with it, and you can get those polygons created, you can easily turn those polygons into points that have your subaddress information built in. A lot less difficult than going out and identifying the indoor spaces for yourself, right? And make great contributions to your foundational RCL and site structure address point databases from the fact that this indoor map was created for somebody else's money, right? So that is definitely the reason that I wanted to bring this convergence to bear today. A question, yeah, will this seminar be available online? Yep, we'll definitely put the recording of this webinar on our YouTube channel. So definitely grab that if you want to share this information with people that are helping answer that funding question, people that are helping to understand Ray Baum's Act and how dispatchable location requirements exist and are out there. Another regulatory topic that I'll just throw at you at the end here is the idea of Alyssa's law, the idea that there should be an indoor map attached to school safety plans. Again, take advantage of the fact that there are things like that out there that will get good, useful data for you that you can turn into good, useful address data as well. Thanks again for joining us, everybody. Have a great day, and we'll look forward to seeing you in March for our webinar.